morning, everybody. Welcome to the Hadoop Summit. Today we are going to have a presentation about Cloudbreak together with my colleague Chris. We're going to do a quick introduction of Cloudbreak, what it does, how it works, and then we do a cluster provisioning demo.
We can't hear you.
Yeah, I know.
We can't hear you.
All right. Try. Is it better now? No. Hello? I was early. Excuse me. Is there a way a bit to make it louder?
I'm working on it.
People can. All right.
Go ahead, it's loud.
Okay. Is it better now?
Yeah.
Okay. Thank you. Yeah, we're going to go through the lessons learned. We've been running clusters on 4 major public cloud providers and private providers as well. Lessons learned on that. And then we're going to do an auto-scaling demonstration. We're going to provision a cluster, submit some jobs, and see how the cluster can auto-scale based on different load. Quick introduction. So Chris and myself, we used to work, both of us, for Sequence IQ. We were one of the founders. The company has been acquired by Hortonworks early last year, so over 1.5 years ago. We are part of Hortonworks. We started to work on Cloudbreak and the auto-scaling part during Sequence IQ, and yeah, we are still continuing to do so through Hortonworks. So about today's speech, quick thing about goals and motivations. What were our goals when we started to do Cloudbreak? Then we're going to describe the technology stack. Few of you might have attended the Cloudbreak demonstration or a session last year. Basically, since then we changed the whole architecture of Cloudbreak and what's underneath. So we are going to dig into that as well. We're going to go through the lessons learned on these cloud providers and best practices. Obviously, due to the short time of the demonstration, there is not going to be enough time to dig into all problems, issues, and lessons we have learned on these cloud providers, but feel free to visit also the Hortonworks booth or just come after the session to discuss if you have any particular questions. Then we do a demo, auto-scaling demonstration. So about the goals and motivation. So what we wanted to do is we wanted to create Hadoop clusters declaratively without having to pre-configure anything. Just bring basically the set of services you want to install on a certain cloud provider and do that. Obviously, we wanted to automate the whole process and unify it across different cloud providers and different stacks without as less configuration as possible. And we wanted to reuse the same process through different life cycles of your cluster. So the very same process we are using on our laptop, we are using on QE, UAT, or production environments. There is no difference at all. Then, obviously, we are a very DevOps-friendly company, and we wanted to do some tooling as well. So beside the UI, which most of the people use, we provided the REST API, which is about to secure then the CLI, command line interface shell, in order to automate the whole process. So you can bring up a Hadoop cluster on any cloud provider, for example, for a Jenkins job. Then obviously security and multi-tenancy, that's part of the cluster. So since Yarn has been introduced, we were very much focused on multi-tenant clusters. Yeah, obviously security is paramount on these things. The last piece for our motivation was basically the SLA-based policy, auto-scaling. So we wanted to give you the option to auto-scale your cluster on different alerts, metrics. We pull out around 400 metrics from the Hadoop cluster, and on each of these metrics you can set up different policies and attach auto-scaling SLA policies to these alerts. Fundamentally, since all cloud providers are pretty much different, we wanted to have a unified process for all these things. So basically hide what's underneath. You have to interact with one API, one interface, or one CLI shell. and we care about the differences under the hood. And obviously, every cloud provider has different compute, network, security, performance, and other options which we have to take care on Cloudbreak. So let's share what we have done and what we have found during these 2 years and 2.5 years since we started to work on Cloudbreak. So the technology stack, it's changed a bit since last year. The key part of the technology stack is still Apache Ambari. So for each and every declarative cluster we are bringing up, we are still using Apache Ambari to set up the HDP or the Apache Hadoop cluster part. So there's no difference at all on this. Obviously, we use the cloud provider APIs, which are hidden under the hood. We support 5 providers right now. Then, yeah, we got rid of Docker in the cluster side because several issues. I'm happy to discuss if you are interested why in deep details. We still use Docker for the microservices for the Cloudbreak application part, but we don't use Docker on the cloud on the HDP cluster size anymore. Instead of that, and instead of Docker Swarm, we use Salt stack in order to orchestrate the provisioning, and in order to build the pre-build the cloud images, we use Packer. So Cloudbreak basically consists of 3 different parts. So if you are about to install Cloudbreak on-prem, obviously we have a hosted version which is there only for demonstration purposes and for quick tries. So we don't suggest to use that in production environments. So we suggest to take the Cloudbreak application itself and deploy it on-prem or on your favorite cloud provider. So Cloudbreak basically has 3 different main pieces. One of them is the CBD, which is we call it CBD, is a Cloudbreak deployer. Cloudbreak deployer is a tool written in Golang to deploy the Cloudbreak application itself. And it's a very DevOps-friendly tool. So basically, it's a single distribution binary for all major Linux distributions. You can take that and install Cloudbreak. There are lots of hardware functions built in. And then the Cloudbreak application itself, it consists of several microservices, around 10 Docker containers. So we got the REST API, we got a UI, we got the OAuth 2-port, we got database running in containers. So all these are running on different containers and microservices. That's the Cloudbreak application itself, and that's deployed and orchestrated by the Cloudbreak deployer, the CBD. And then once you have the Cloudbreak application installed, then basically you can go there and use the toolings which we offer, like the UI or the REST API or the shell, and provision a cluster on your favorite cloud provider or your chosen cloud provider. So Cloudbreak deployer. As I said earlier, it's a single binary written in Go. It has only one dependency. It requires Docker version 1.9, so you have to have Docker installed on the machine where you are about to deploy the Cloudbreak application itself. Obviously, this is in the case when you are deploying the Cloudbreak application on-prem, but we are making on every cloud provider we are offering pre-built cloud images which you can just start, and that's going to start the Cloudbreak application. So if you want, you can take that image, for example, on AWS and run it, so you don't have to deploy the application itself. There are pre-burnt images on all major cloud providers. So yeah, you can do the installation on any Red Hat, CentOS, Oracle Linux, or use the image. And then there are a couple of operational supports built on the Cloudbreak deployer. You can easily upgrade and downgrade Cloudbreak versions. So obviously, we release when we are releasing new versions of the application, you don't want the world to stop, so you can use the Cloudbreak deployer and do an automatic migration of the schema, for example, or an upgrade and downgrade using the Cloudbreak deployer. There are lots of support for different cloud providers built in. The major ones are like we use IAM roles on AWS, so we can generate roles. We have automated the whole role generation process, so you don't have to go to the AWS UI or shell and create those roles. And also, on Azure, we use Dash and WASB, and we automated the whole configuration through Cloudbreak deployer. So that's we are saving you like 50 clicks, for example, if you do this through the UI. And then there are a couple of utilities built in. As I said, there is a shell, the Cloudbreak shell, with CLI, and Cloudbreak deployer can start an instance of the shell, which is interactive, connects automatically to either your local Cloudbreak application or a remote one. You can automate different test executions using the Cloudbreak shell. You can generate OAuth2 tokens, for example, if you want to call the REST API, but you don't really have any OAuth2 experience, then you can get a token with the Cloudbreak deployer through the shell in order to access those endpoints. And then if you want to deploy, make your custom Cloudbreak feature, or you just want to run, see how it works in your ID or whatever you are using, then basically there is a local development environment setup which is automated. We make sure that we deploy the microservices and basically you don't have to do anything, just start your ID and connect to that, and you can run Cloudbreak from there as well. So the second part is the Cloudbreak application itself. As I said, this consists of a bunch of microservices, over 10, if you consider all the databases and the supporting like Logstash and other stuff, Logsync we use. So the installation of Cloudbreak application can be automated with a Cloudbreak deployer. You could do it manually, but it takes lots of time since you need to start all these microservices. You can do it in 20 seconds with Cloudbreak deployer. Then there are a couple of operations available through the Cloudbreak applications. The major ones I'm not going to highlight because there are lots of features, but these are the main ones. So basically, there is a consistent set of features through the UI shell or API. So everything what you can do through the UI or the REST API, you can do through the shell, and the other way around. So you can build your own UI if you are not happy with the one which we are giving you, or just use basically the REST API or use the shell if you prefer that. Obviously, the application it's multi-tenant, the Cloudbreak application itself. I did mention that we are using OAuth2, and behind the scene we are using Cloud Foundry's UAA for authentication and authorization, basically to issue those tokens and to basically do the user management. In Cloudbreak, everything is a resource, and every resource has an attached scope. So basically, you can create different ACR setups and attach to these scopes, and you can restrict people from your organization what can do and what can they not do with through Cloudbreak. Currently, the users of Cloudbreak are stored in a database, but UA can be configured to take the users from LDAP or AD or other. You can authenticate through Facebook or Google. Basically, every provider which has an OAuth2 can issue an OAuth2 token. You can reuse that with Cloudbreak, so you don't have to duplicate your user management. And then there are usage reports. So all these users, so the Cloudbreak application, if it has, we have the concept of accounts, and you can invite your colleagues under the account, and then we generate usage reports, so you can see that who has been launching clusters on which cloud provider, which region, how many nodes, what Ambari host groups have they used. So basically, you can drill down on very deep details through the usage report to see who's doing what, and restrict people to not launch clusters over 1,000 hours per month, for example. Then through the application, you can set up custom stack repositories. Obviously, by default, if you don't do anything, we give you the HDP stack as a custom repository. But if you have a custom stack, then basically you can take Cloudbreak can take the RPMs from there. Actually, this is an Ambari feature. Then we support different failure actions. So, for example, if you are asking for 1,000 nodes for your cloud provider, but the cloud provider is going to be able to give you only 500, then you can say like, okay, I want to roll back the whole stack provisioning, or you can say, okay, I go ahead with best effort, give me what you can, and I still want my cluster to be provisioned for X number of nodes. You can set up like percentage or fixed number of nodes. So there are a bunch of configurations you can do with Cloudbreak in order to configure these failure actions to make sure that you got what you need. And basically your SLAs are okay. Then there is a event history and cluster management built in Cloudbreak, so you can go through the event history, like how long the stack provisioning has been taken, what's happening under the hood. You can step back, you can basically restart the whole flow from different stages. It's like a state machine built in. So if you have some failure actions, then basically you don't necessarily have to go back to the very beginning and start the whole stack provisioning from the beginning. And then there is SLA-based auto-scaling. As I said, there are 400 metrics which we are pulling out from the Hadoop ecosystem. So basically all the metrics which are available through JMX or other means from your Hadoop stack, then we are pulling out all these metrics, and you can attach different alerts to these metrics. And then you can attach different SLA policies, auto-scaling policies to these alerts, like upscale, downscale, whatever you want. And then, yeah, basically Cloudbreak enforces these policies. As I said, then we support different cloud providers. So on public side, we support Azure, AWS, Google Cloud Platform, and then we support OpenStack, different versions of OpenStack. And we have as a tech preview, we support Mesos as well, if you have a Mesos installation on-prem. The API which we offer for you through Cloudbreak, it's agnostic. So basically we hide all the details of AWS, Azure, Mesos, or whatever it's under the hood, and you always reusing one UI or one API or one shell, which is agnostic. And if you want to move your workload from AWS to Azure or the other way around, basically you really don't have to do anything but provide bring your credential and reuse the whole stuff you have created. So it's very easy to migrate from cloud provider or basically run parallel jobs on different cloud providers and see which one fits you best. As I said, we support 5 providers, but there is an SPI interface under the hood, so all the default providers are hooked in through the service provider interface. You can bring your own stack under Cloudbreak management. There are a couple of folks from different companies out there who, in the community, who have built their own stack and brought it under Cloudbreak management, different OpenStack versions, so other cloud providers. We also got back some contributions. So basically, these are a bunch of Java interfaces, and the happy path to integrate a new cloud provider under Cloudbreak usually takes 2 weeks. So it's very easy to bring a new cloud provider under Cloudbreak management if you don't want to use the default ones which we offer. And then the clusters. So the third part is basically you provision the Hadoop clusters with Cloudbreak. So the installation of these clusters are managed by Cloudbreak. We support in the HDP stack. If you choose HDP by default, then basically we support around 25 components. So we support. You can automate and install these components with Cloudbreak. Basically all the full stack, so there are no restrictions. If something is available through Apache and Barry, then you can do so with Cloudbreak. Let it be Spark or Storm or Kafka or whatever you are about to use. You can install and automate the whole process with Cloudbreak on the cloud provider side. By default, we optimize the configs on the cloud side and on the stack side as well. I mean on the Hadoop stack side. So all these configurations either are specific to cloud provider or the components you have installed. So we offer defaults, and we apply those defaults out of the box. But obviously you can override those defaults if you have some custom needs or you know better than the default ones. Regarding the operations, yeah, you can take the offer. I did mention the custom stack services. So with Cloudbreak, you can configure. There are a couple of domain models which are showing up on each and every cloud provider. Usually these are like like network, storage, security. So although each and every cloud provider has a different implementation, if you're looking for a bit higher level, the domain model is the same. So with Cloudbreak, we offer basically you can customize all these components, which we're gonna show you during the demo. You can customize basically the whole network infrastructure, or the whole infrastructure underneath Cloudbreak can be customized, and then we apply those customizations on the cloud provider side. The Hadoop cluster is a declarative one, so basically it's based on Ambari, and we are using the blueprints, which is a JSON file, so you can stick your services in that blueprint, send it to Cloudbreak, and then we install those components and those services on the cloud side. One of the key things in Cloudbreak is that, for example, obviously usually people run different components, but not all components requiring the same hardware or the same instance. So Cloudbreak gives you the option to create heterogeneous clusters. So for example, if you architect the cluster, your Ambari blueprint in such a way that, for example, you put your Spark components within a host group, and then you put Kafka or Storm in a different host group, then the instance types which we are launching can be customized, and for Spark you can give high memory instance types. For Storm you can give high I/O, for example. So there is no restriction that the whole cluster has to be homogeneous and all the instance types are alike. You can customize the whole one, and we automate the process behind. So you don't have to, basically you just tell us infrastructure templates. We're gonna show you in a minute. The network, obviously it can be customized. We support, you can, by default, if you don't do any customization, then we create a isolated network stack for you, which is not available for the outside world. But you can create subnets. You can reuse your own VPC if you already have a private network on the cloud provider side. You can reuse that. You can launch different. We can create few different subnets within that VPC. So there are lots of ways to customize the network stack as well. Obviously, storage in the cloud is pretty important. So there are default options on different cloud providers. For example, on Microsoft Azure, we go with WASB. On AWS, HDFS is the default. So we provide all the available storage types which are available on that cloud provider. Let it be block storage or blob storage or root disks. We give you the option to choose whatever fits your workload the best. And then security, it's a pretty important thing, especially in the cloud. So first of all, the access to the cluster happens through edge nodes, which is secured. You can lock down your own cluster. We Kerberize your cluster with one click, so the whole pain of Kerberization is going to go away. You can automate the whole process. We push all the key tabs to the nodes, so everything what's happening behind the scene. We support SSSD and free IPA on the security side, so basically you can bring your AD users or AirDoc users, and you can create basically these roles in order who can launch or actually who can submit jobs into this Hadoop cluster. And then on the utility side, we provide different Ambari views, and then we also give you the option to create temporary and ephemeral and long-running clusters, and basically share metadata within these clusters. So quickly, let's quickly go to the lessons learned, and then we do a demo, because I realized we don't have too much. Oh, there's still elapsed time. Oh, there is enough time. Okay, so let's just very quickly what I was telling you here is so this is how Cloudbreak looks like, and the only thing which is cloud provider specific beside the template is basically the credentials. So in order, when you are about to launch a cluster on Cloudbreak, then you need to create your cloud credential. There is role-based credential or key-based credential. This is specific to each and every cloud provider, so not gonna enter in these details. Regarding security, basically we support. There are we either open you all the ports or we allow you to SSH only and SSL on the cluster, but obviously you can customize this and you can create different security groups which will apply on the cloud provider side. Specify the protocol, the port, the CIDR. Then on the template side, so there are a couple of default templates, but basically templates are describing your cloud infrastructure. So for example, if you take AWS, then you can create templates. You can let us know the instance type. You can let us know what kind of volume types you want to use, whether it's magnetic, FMR, or SSSD. You can specify how many volumes and the size of the volumes you're about to attach. You can specify the spot price if you are about to use spot prices on AWS, for example. Then we can do EBS encryption. We can encrypt the volumes, the block volumes if you want. So these are the templates, and obviously you can create different templates for different cloud providers and different host groups, and attach that to the cluster which is about to be created. Blueprints are the Ambari blueprints. Again, there are a couple of default ones. If I choose this Zeppelin-based one, then basically these are the host groups which I was telling you before. So each and every host group can have different templates attached. So you don't have, if you lay down your host group in a good way, then basically you're going to get a very good performance out from the cloud provider. Then there are a couple of other things, like for example on OpenStack, we give you obviously on the cloud side, one of the key features of Hadoop is data locality, which is not always working on public cloud providers. On private cloud providers, like for example OpenStack, we give you the option to either upload a mapping file, which Cloudbreak is going to use, and let Hadoop know that where your data resides to get data locality, or basically if you don't have that, then you can let us know which hypervisor running on which rack, and then we attach that and we're going to create a mapping file out of that. Regarding the cluster provisioning, so once I choose a credential, then basically I can go through a cluster provisioning through the UI. You can specify the username and the password for Ambari. You can specify regions on different cloud providers. Obviously, you have different regions. I choose the OpenStack because it's faster in our case right now to the internet. So basically, you can choose HIT or native provisioning. Down on the security and network side, you can choose the network stack. You can choose a security group. If I enable security, this is the Kerberization of the cluster. The only thing you need to do is just basically let us know a master key and the username password, and we're going to Kerberize the cluster behind the scene. Then you can choose your blueprint. These are the stack options which I was telling you. If you are happy with defaults, then you can choose the right option. If you are not happy with defaults, you can create yours. Each and every host group can have different templates, so the templates are basically the infrastructure. So this is how we make heterogeneous clusters. Then these are the failure actions. So for example, if I'm asking for 100 node and I'm only going to be able to enter 100 node, I either roll back or I just take the resources which I get through best effort. Then you can configure the different HTTP repository or other repositories for RPMs, which we are about to install. And the last part is basically it's a review and launch, and then we provision the cluster for you. So let me quickly go through the lessons learned, and then Chris is going to do an auto-scaling demo using Spark and Zeppelin. So on the lessons learned part, so the most important thing is that basically not all cloud providers are the same. So first of all, you need to consider which provider is going to use, and then because each and every provider has differences in performance, storage, and functionality. The second important thing is basically you need to do some planning ahead, capacity planning in most of the cases. So based on your workload type, most likely you know whether you want to do batch or interactive or ad hoc queries or long-running services. Then you need to choose different instance types, and you need to get familiar on the cloud provider side of which instance type is good for what. Use heterogeneous clusters, so leverage the cloud. Your cluster doesn't have to be homogeneous. And then if you are doing something wrong through your POC process, then there is no problem. Basically, it's just the cloud, so you can do a quick trial and error and see which instance types and which settings are fitting you best. It's very cheap, and basically you can iterate through the whole process. Yeah, and obviously, since it's the cloud, you can start small and then auto-scale when you have to. The most important thing in each and every cloud provider, what we have seen so far, is like storage. So you have lots of options on each provider. You have ephemeral storage, you've got block storage, blob. So you need to make sure that if you are storing your data on S3, for example, then yeah, you are going to make some assumptions, and you will have to live with that. What basic Hadoop does bring compute to storage, which is not always the case in the cloud provider. As I was telling you, on OpenStack and other private providers, we do our best to do data locality, but in the cloud, basically everything is a service. Even on disk, if you are using block storage, then basically it's as a service. So it might be attached or might not be attached. Most likely it's not, and it's somehow remote from your compute node. So basically, you need to partition your data and scale independently. Storage and compute has to be scaled independently because it's not like on a physical environment. Obviously, on the security side, you need to use strict security rules because of the cloud, like private subnets. You need to restrict access, use edge nodes. So if you go to provider side, so AWS. If you are about to use transient load, then basically you have to, the best instance type is like C or C4, M4. If you are doing long-running clusters, H2, D2, it's a good instance type. But again, your workload defines all this. So these are indications based on our experience, but it might fit or might not fit you. We suggest to iterate and make some performance tests and find the best which fits your workload. Obviously, there are people who are doing under different regulations like HIPAA or financial regulations where you are not allowed, other people are not allowed to run compute tests alongside your cluster. So in that case, on AWS, you would have to use dedicated instances, which Cloudbreak supports, by the way. Yeah, storage. So basically, the most important thing you need to note and that is like S3 gives you only eventual consistency. So the data, it might be there or might not be there for a while after the commit. So we need to live with this. I suggest to take there is going to be a session by Hortonworks, I think tomorrow, about the new features we have added in HDFS in general, and the file system and the S3A driver implementation, which tries to solve all these problems and the optimizations we have done for the cloud. The network, it's a good experience we have seen is that basically most of the people are starting out from CentOS or Red Hat-based networking, and we realized that like Amazon Linux, was way faster, and basically it was due to the networking, different networking configurations of different networking libraries, newer ones. Also on the network side, you need to make sure that consider the instance size, like not all instances can use a 10 gig network. Yeah, and on security use VPC and all that stuff. So basically, that's a good diagram of the networking. So if you don't use enhanced networking, that's the cost you are going to pay. So lower is better. And the other measurements, basically there are no differences between spot and not spot instances regarding I/O. So feel free to use spot instance types. I'm going to quickly do the Azure one, and then I'll let Chris do the demo because we don't have too much time. Yeah, let's do this after the talk because we have like 6 minutes and we want to do an auto-scaling demo. Sorry. So, yeah, so basically on Azure, the most important thing what we have learned is like the storage account has IOPS limitations, so you need to scale across different storage accounts. For that, we introduced a Dash service. So Azure has something called Dash, which basically it's a load balancer across different storage accounts, and you would use Azure Blob Storage. think, yeah, Chris, I'll let you do quickly the demo because we don't have too much time. But so the Google, OpenStack, and Mesos. If somebody has some questions, just come over after the session. Don't too much.
Out of time, let's go quickly through the demo. So what we are going to do is we are going to submit a Spark job through Zeppelin, which is coming in HDP 2.5 as a technical preview. So as Janos mentioned, we can do auto-scaling of your clusters, and those auto-scaling rules can be based on host groups, which means you can attach scaling policies to certain Ambari metrics and Hadoop metrics, and you can scale your cluster up and down at the same time. So what in this demo we are doing is that we are creating an alert for pending yarn containers, which means if we have too many applications running and the cluster resources are running out of space, we can upscale those clusters and the data nodes and the compute nodes as well. So what we are seeing here is that we are creating for the host group slave 1 auto-scaling rule, which will add 10 extra nodes if we are running out of capacity from the cluster, which based on the pending yarn containers. Once these are done, so there's a 20 data node and 2 master nodes for HA. So as we can see, there are 20 active nodes and nothing is running on the cluster yet. And if we go to Zeppelin, there is a submit notebook, and we are going to submit the simple Spark P job, which is going to run as long as it's needed. We're going to see that this is based on the Spark dynamic resource allocation, which means Spark is running as many executors as you need based on your workload. So if you have an heavy workload, then it means Spark is going to request more and more executors. But in this case, since we have 20 data nodes, we are not going to have too many executors. So what Cloudbreak is going to do is to upscale your data nodes, and then Spark can add more executors to the job. As we can see on the resource manager, the Spark job is already submitted, and the executor started to run. And if you can take a look at the nodes, you can see that the containers are running on all nodes. And if you look at the yarn capacity, then you can see it is almost fully used, our cluster. So what's going to happen is that we have these many executors, and we have no more room for new executors. What's going to happen is that the alert is going to trigger an upscale, which means we are going to add 10 extra more nodes to the cluster. As you can see, the pending yarn container alert is already in critical state. And if we move forward, we can see that Cloudbreak has already started adding the 10 extra nodes to the cluster. So this cluster is based on running on OpenStack. So it's going to start the instances, install the Ambari agents, and start the agent and join it to the cluster. And once it's done, Ambari is going to install the required services defined in your blueprint. As you can see, it has already started installing the services, and our job is still running. Once the installation is done, without any resource manager restart or something like that, the data nodes are going to join to the resource manager, the node managers are going to communicate with it, and what's going to happen is that based on the dynamic allocation configuration of Spark, it is going to request more executors to run the job. As we can see, the data nodes already started to join, and those are already running containers. All the extra 10 data nodes have joined, and all of them are still running containers. And if we go back to the Spark application master, we're going to see new executors have been added to the job, which means it is going to allow us to execute the job faster than it is normally would have executed on the 20-node cluster. So the cluster is upscared, and the executors have been added to the job. So that's how auto-scaling works for upscale. So the same way you can do is you are downscaling. So if your cluster is pending, does not do anything, you can simply downscale it, and it will gracefully shut down the nodes, and you are not going to lose any data at all. So if you're interested in this, seeing this live, you can come to our booth and we can show it to you, but I think we are out of time already.